Hi guys, so welcome ulit sa ating Module 14 and it's all about moving loads. So sample number 2 na tayo. So sabi dito class, repeat problem number 1 using axle loads of 30 kN and 50 kN on a wheel base of 4 meter crossing an 8 meter span. So tinatanong lang ulit dito class is what is the maximum shear and then what is the maximum moment. Okay, so for that, drawing ulit muna natin kung ano itsura ng magiging span ng ating beam. So that is 8 meters. So lolocate ko agad yung gitna niya, no? So therefore, yung center line is 4 meters. 4 meters. Then after that, i-drawing naman natin yung configuration ng ating moving loads and then locate natin yung resultant load and then kunin natin yung amount ng resultant load nila. So let's say ito yun. So isang 30 saka isang 50. So let's say P1 30 kilonewtons and then P2 50 kilonewtons. Now, kunin natin yung resultant. Anyways, ang distance between those loads is 4 meters. So, mas malapit yung resultant dun sa mas mabigat. So, dito natin lagay yung R, which is equal yung sa 30 plus 50. So, therefore, 80 kilonewtons. Now, kunin natin yung distance nito. Let's say ito is distance X. So, take tayo ng moment at under ng load P2. So, take tayo ng summation of moment. At 50. So, moment to, moment din to. So, P1 times distance is 4 is equal ngayon sa resultant load and then yung moment arm is X. So, 30 times 4 is equal to resultant 80x. So, therefore, x now equals 1.5. So, therefore, ang distance ngayon ng resultant load measured from P2 is 1.5. So, kung 1.5 yan, ilan yun dito, class? So, kung 4 yan, 1.5. Therefore, this one is 2.5. Okay? After that, pwede na tayo magkuha no? Let's say, unahin natin yung maximum moment. So, kunwari gusto natin kunin yung maximum moment under dun sa load P1. So, tatawagin natin yung for M1 maximum. Okay, so therefore, ang kino-consider natin is P1 and then yung resultant load. So, ang distance between them is 2.5, diba? So, therefore, yung kalahati ng 2.5 is 1.25. So, ang gagawin natin, measured from the center line para makuha natin yung M1 max. So, locate natin 1.25 to the left yung P1. So, let's say, dito yun. So, yung distance na to is 1.25. So, P1. And then, 1.25 to the right, doon naman natin ilocate yung resultant. 80 kilonewtons and then this distance is 1.25 din. And then after that, ipasok na natin yung isa pang load na P2. So, P2 is 1.5 to the left or to the right nung resultant. So, 1.5. Let's say, pa ganyan yan. So, P2 is 50 kilonewtons. So, distance nito is 1.5. Now, let's check kung magiging correct or logical yung mga values natin. So, if this one is 4, 1.25, 1.5, ilan yun dito, class? So, 4 minus 1.25 minus 1.5. So, 1.25 din dito. So, therefore, pasok pa tong load P2 doon sa span natin. So, this one is 1.25. Ilan yan dito, class? So, 4 minus 1.25. So, this one is 2.75. Okay? And then, after nyan, class, ano na nang gagawin? Kung gagawin natin, magmo-moment tayo dito, diba? So, we consider kung anong reaction lang kukunin natin. Is it yung reaction, let's say, at A or yung reaction at B. Okay, so ano ba yung magiging consideration natin dito, class? Mag-moment tayo dito, di ba? So, ang gagawin natin dyan later on is ikakat natin siya and then i-consider natin yung mas konti yung analysis. So, that is yung left. So, therefore, itong RA yung kukunin ko. So, para makuha yung RA, so take tayo na summation of moment at B is equal to 0 considering clockwise moments positive. So, that RA times the moment arm is 8 and then minus. So, instead of using yung mga individual concentrated load, so yung resultant na lang gagamitin ko, which is yung 80. And then yung moment arm ng 80 is itong 1.5 plus 1.25. So, that is 2.75 equals 0. So, solving for RA now, that is equal sa 80 times 2.75 divided by 8. So that is 27.5 kilonewtons. So it is 27.5. And then now, considering yung left section. So for the left section, ganito siya. So andi dito yung 27.5. And then dahil kinat natin ito, so lalabas yung positive bending moment. Paano yun pag ganito? So tawagin ko siyang M1. So, wala na ibang loads ka nakikita, di ba? So, this distance is 2.75. So, by taking summation of moment at point 1 is equal to 0 considering clockwise moments positive. So, clockwise ito, 27.5. The moment arm is 2.75. And then ito, minus M1 is equal to 0. So, solving for the M1, which now corresponds doon sa ating maximum possible M1 ng M1 max. So that is equal saan? So sagot is 75.625 kilonewton meters. Okay, so yun yung pinakamalaking M1 na mangyayari dun sa ating beam wherein kapag ang gulong natin is nandito na siya. Okay, kapag nandiyan dyan na yung orientation ng ating mga wheels. But that doesn't mean na ito na yung maximum design moment natin. So therefore, consider naman natin yung isa pang gulong which is yung P2. Okay, so dito naman tayo. So let's say consider natin yung P2 saka yung resultant. So locate natin yung gitna nila. So kung 1.5 ito, yung gitna niya is 0.75. So locate naman natin yun sa center line ng ating beam. And then, masasolve natin yung M2 max. Okay? So, let's say, ito yan. So, center line. So, 4. This one is 4. And then, sabi, locate natin yung gitna, no? Nung considered load natin and then yung resultant. So, 1.5. So, 0.75. So, dito is yung P2 na 50 kilonewtons. So, ang distance nito is 0.75. And then, on the left side naman, dito yung resultant. Which yung distance is 0.75 din. And then, 2.5 to the left is P1. So, lagay ko dito. P1 is 30 kilonewton. So, this one is 2.5. So, check natin class logical yung mga distances. So, kung 2.5 to, 2.75, ilan pa yung dito class? So, 4 minus 2.5 minus 0.75. So, yung distance dito is positive 0.75 pa. So, therefore, possible pa nasa loob yung, yung wheel 1. So, dito is ilan? So, 4 minus 0.75. So, this one is 3.25. Okay, and then after that, kunin natin yung mga reaction. So, RA and then RB. So, pili ka class, bago ka kumuha ng reaction. Ano ba yung i-consider mo dito pag nag-cut tayo dun sa, kasi since P2 yung kino-consider natin, so kakat natin to. So, ano yung consideration mo? Left or right? Dun tayo sa right, di ba? So, therefore, ang kailangan ko lang na reaction is yung RB. So therefore, ang gagawin ko, magte-take ako ng summation of moment at A is equal to 0 considering clockwise moments, positive. So, ito, yung resultant na lang. So, 80 times the moment arm nito is, ito, 0.75 plus 2.5. So, that is 3.25 minus RB, the moment arm is 8. So, equals 0. So, ilan ngayon yung corresponding RB for this orientational loads? So, 80 times 3.25 divided by 8. So, that is 32.5 kilonewtons. Okay, so meron na akong RB. So, pag may RB na, isolate na natin yung right side. So ganito, no? So, dito merong 32.5. So, dahil ito yung cutting point natin, lalabas yun yung positive moment, which is ganito yung direction. Tawagin natin M2 since that is under load P2. Okay? So, ang distance nito is 3.25. So, by taking summation of moment at 2 is equal to 0 considering clockwise moments positive. So, clockwise, so M2, and then counterclockwise, so minus 32.5, and then moment arm is 3.25 is equal to 0. And then yung M2 na masasolve natin dyan ngayon corresponds dun sa pinakamalaking possible value ng M2 na mangyari dun sa ating beam. So, ilan yan plus? So, 32.5 times 3.25. So, sagot is 106.625 kilonewton meters. Okay, ito na yung pinakamalaking possible value ng M2 doon sa ating beam. Okay, na kapag ang gulong natin is nandito siya naka-orient. So, dyan siya nakapatong. So, anyways, mayroon tayong nakuwang dalawang moments. So, that is 75 and then 106. So, ano yung pinakamalaki dyan, class? Ano yung magiging Mmax talaga? Ito yung pinakamalaki sa dalawa, which is yung 106.625 kilonewton meters. So, ito na yung final answer natin. Okay? And then, lastly, for the maximum shear. So, for Vmax, okay, so paano gagawin? Ilolocate natin yung mga loadings natin wherein yung resultant is nearest doon sa support. So, dahil mas malapit siya ulit doon sa right side, no? Kasi ang gagawin natin, yung gulong, lalagay natin as either dito or dito siya, no? So, since yung resultant is mas malapit siya doon sa right, so sa right na, support natin siya i-orient. Okay, so magiging drawing niyan is ganito. So, nandito yung P2. Okay, and then 1.5 to the left is yung resultant. And then, lagi ka to 1.5. And then, 2.5 to the left ng resultant is yung P1. 2.5. So, ilan yung matitira dito, class? Diba total of 8 ito? So, 8 minus 2.5 minus 1.5. So, 4. Okay. So, sabi natin kung saan pinakamalapit yung resultant na support, yung support na yun, doon natin makukuha yung pinakamalaking reaction, and then that maximum reaction corresponds dun sa ating maximum shear. So, ito ngayon yung kukunin natin na yung RB. Okay. Pero meron pa rin naman ditong RA, pero hindi na natin siya hahanapin. So, yung RB kukunin natin. Para makuha yan, take tayo na summation of moment at A is equal to 0 considering clockwise moments, positive. So, itong resultant na lang i-consider ko clockwise. So, yung resultant which is ilan to? Ayan, 80. So, therefore, 80 times yung moment arm niya is 4 plus 2.5. That is 6.5. And then ito, counter. So, minus RB, the moment arm is 8 equals 0. So, masolve natin yung RB which now corresponds dun sa maximum shear. So, ilan yan, class? 80 times 6.5 divided by 8. So, this one now is 65 kilo newtons. Okay? So, ganun lang siya, no? So, let's check kung tama ang ating mga sagot. So, 105.625 and then 65 for the maximum shear. Okay, so bigyan lang kita ng idea, no? Kasi nangyari dito, ang ginagawa nating solution is we take yung or we solve for the value ng M1 max and then we solve for the value ng M2 max. Ang clue dito, class, no, para hindi mo na gawin yung dalawa, kadalasan, okay, nangyayari yung pinakamalaking moment doon sa dun sa pinakamalaking loading. So, sa case na to, mas malaki yung P2. So, ang pwedeng gawin mo, mag-start ka na lang agad sa pagsasolve ng M2 max kasi siya lang din yung mag-govern. So, just like dun sa previous example natin, napapakita ko lang, which is nandun sa naunang video natin, yung part 1. So, kung ito titignan mo, class, P1 is 40, P2 is 60. Kinuha natin yung M1 max under ng 40. So, ito yung lumabas. And then, kinuha natin yung M2 under dun sa P2. So, ito yung lumabas. Saan yun? Ito. So, di ba nakita mo, class, nag-govern? Mas malaki pa rin talaga yung moment under dun sa greater or larger weight. Okay, so just in case gusto mo lang mapabilis yung analysis mo. So, let's say 2-wheel load lang siya. So, proceed ka na agad dun sa mas mabigat. Kasi doon, kadalasan nag-exist yung maximum moment. Okay, so anyways, proceed na tayo sa next sample problem natin. So, sabi dito, a tractor weighing 300 pounds with a wheelbase of 9 feet carries 1,800 pounds of its load on the rear wheels. Compute the maximum moment and maximum shear when crossing a 14 feet span. Okay, so ang binigay dito, class, yung overall weight na ng tractor, which is yung 300 pounds. And binigay rin, class, yung weight, portion ng weight na yun carried by the rear wheel. Okay, so let's say first drawing muna natin yung yung beam natin. So, ayan. So, ilan to? 14 daw, no? So, 14. So, therefore, at center line, this one is 7, this one is 7. And then, so yung tractor, so 2-wheel, lang din naman siya orientation, no? So, pakita ko yan dito. So, pag ganyan siya. Okay, ang sabi, yung rear end niya or yung rear wheel niya is nagke-carry siya ng 1.8. So, tawagin ko itong P1. So, therefore, dito is meron daw 1,800 pounds. And then, binigyan ba tayo ng distances? So, wheelbase of 9 feet. So, distance nito is 9 feet. And then, sabi, a tractor weighing 3,000 pounds. So, sabihin yun yung overall. So, parang sinasabi natin yun yung resultant. Okay, so therefore, sinabi yung resultant weight daw niya, total weight, R, is 3,000 pounds. Okay, so therefore, we now need first to solve for the load carried naman ng front wheel natin, which is yung P2. Okay, ilan yung P2, class? So, madaling-madali. So, kung 3,000 yung total, 1.8 ang kinikerry nung nasa likod. So, therefore, this one is 1,200 pounds. Okay, and then same steps na ulit tayo, no? So, we first solve for the location ng ating resultant load, which is X, distance from P2. So, take tayo ng summation of moment at the load 1,200. So, gawin natin, moment natin itong P1. So, 1,800, the moment arm is, sa P2 is 9 while yung resultant, ang moment arm niya is x. Okay, so 1/8 times 9 is equal sa 3,000 times x. So, ilan x distance? So, dahil mas malaki tong 1/8, so dapat mas malapit siya dito sa ano, no? Sa larger weight. 1/8 times 9 divided by 3,000. So, sagot is 5.4 feet. So, therefore, kung lagyan natin yung mga distances dito, ito is 5.4. And then, yung remaining dito is 9 minus yon. That is 3.6. Okay? Okay, ngayon, gamitin na natin yung sinabi ko kanina, ano, kasi yung kinukukunin natin dito yung maximum moment. So, saan ba mag-occur yung maximum moment, class? So, base sinabi ko sa previous problem natin na it is located doon under dun sa larger weight, which is sa case na to, P1, P2, mas malaki tong P1. So, therefore, sure na ako, class. Or try mo pa rin, no, kung sakaling gusto mong i-verify. Pero ako, sure na ako that yung maximum moment is mag-occur siya dito sa under ng load P1. Okay? So, isang moment na lang gagawin ko, class, para mas mapabilis. So, for M1 max, na i-consider natin is itong under ng P1. So, M1, which is, ito na rin yung M max. Okay. So, paano gagawin? Ilagay natin yung midpoint between P1 and then yung resultant doon sa center line. So, kung 3.6 ito, so 1.8, no? So, therefore, dito yung P1, 1.8. And then, distance niya dito is 1.8. And then, to the right, meron naman dito yung resultant. So, distance is still 1.8. So, 3,000. And then, 5.4 to the right. Yung P2, 1,200 pounds. So, the distance nito naman is 5.4. Now, bago ka mag-proceed sa pagkuha ng mga reaction, always check if possible na maging ganyan yung orientation ng gulong. I mean, pasok pa ba talaga? Or logical pa ba yung mga distances? So, kunin natin to 7 minus 1.8 minus 5.4. Oops! Is it mali? 1.8 5.4 7 minus 1.8 5.4. Ano lumabas, class? Negative 0.2. Gets ba yun, class? Negative pala to, class. Ibig sabihin, hindi, kapag ginawa natin, nilocate natin yung P1 saka yung resultant ng ganitong orientation, yung isang gulong is nasa labas na. Gets ba? Yung tamang drawing neto is parang ganito, class. So, ito yung center line. So, andito yung P1. Andito yung resultant. And then, yung isang gulong, since 5.4 siya, so, andito na siya. P2. Okay, so ganyan pala yung nangyari. Which is, class, kapag ang isang gulong is outside na doon sa ating span, di, class, hindi na ito yung resultant. Hindi na to 3,000. Kasi ilan na lang ba yung nakapatong sa gulong mo, class? In 3,000 kasi lalabas yan kapag yung both wheels natin is nakapatong dun sa span. Diba? 1.8 plus 1.2. So, 3,000 na yung resultant niya. Pero sa case na to, kung ang nakapatong na lang, class, is yung P1 na 1.8, di ilan yung resultant, class? Di dapat 1.8 na lang din. Tama ba? Gets ba yun? Kasi hindi na to nakapatong eh. Okay? So, sabihin mababago yung ano natin, no? Yung analysis natin. So since P2 is outside the span, ang mangyayari, ang consideration na lang natin is yung P1. Tapos at the same time, yung resultant load, hindi na rin siya dyan nakalocate. Tama ba? So mangyayari kung hindi na natin i-consider tong P2, no? Ayun, no? Since P2 is outside the span, so hindi na siya i-consider. So ang tinitingnan na lang natin na load is yung P1 na lang. Okay, so which is 1,800. So kung P1 na lang yung tinitingnan natin, nasa na yung resultant niyan, class? O di dahil nag-iisang load lang siya, yung resultant ando doon din sa kanya. Tama ba? Which is yung resultant na yun is 1,800 lang din dapat. Tama? Tapos yung location niya, hindi doon lang din sa location ng P1. Okay, kasi nag-iisang load lang siya. So ibig sabihin, nasan ba yung gitna nito? Wala nga silang distance, di ba? So sabi, di ba, yung general rule, dapat yung midpoint between doon sa load and then doon sa resultant, which hindi dito yung mid nila, is dapat i-locate natin doon sa center line ng ating beam. So mangyayari, ganito ang orientation na mangyayari. So ito yung center line, which is 7, 7. So ilo-locate daw natin, no, yung gitna netong dalawa doon sa center line, which is parang ginawa mo. Ayan, nilagay mo lang sa gitna yung yung load na P1, which is 1,800. Okay, so ayun na yung clue doon, class, ha. Kapag pala single load lang or single concentrated load lang yung nagmo-move, iisa lang siya. Kung titingnan mo, class, kung iisa lang siya, dapat located siya dun sa gitna agad, automatic. Okay? And then yung paglalagay dun ng concentrated load at midspan, yun yung magbibigay ng maximum moment. Okay? So anyways, class, hindi na pala natin sure, no, kung ito yung M1 kung siya yung maximum moment, no? Kasi nga nagkaroon ng pagbabago dun sa analysis, so hindi na natin pwedeng sabihin siya yung M-max. So ang gagawin natin, still consider natin siya or ito. Pero sure pa rin ako, kasi mas malaki pa rin siya. Anyways, para hindi tayo bias. So analyze natin parehas, no? Okay. So ayan, no, proceed na tayo sa pag-calculate. So kung ganito na pala yung orientation, so makikita mo yan, So, di ba, ang distance nitong P1 sa P2 is 9. So, tama, no? Kung 7 ito, somewhere here, andi dito yung P2, which is, dahil outside siya dun sa span, so hindi siya part ng analysis. Okay? Gets? So, ito lang. So, simply, we can get yung reaction, no? Kasi dahil nasa gitna siya, so therefore, symmetric din yung values nito. So, this one is A, this one is B. Okay, and then ilan yung RA, saka ilan yung RB. Okay, so dahil symmetric yan, so paghahatian nila itong 1,800. So therefore, ito, hindi ko na gagawin yung summation of force vertical. Ito magiging 900. Ito is 900 din. Okay, since symmetrical. And then, ngayon, kunin na natin yung moment under dun sa load P1. So, cut natin siya. So, we consider yung left side. Consider natin yung left side. So, ganito yung mangyayari dyan. So, dito is merong 900, distance is 7, and then dahil kinat natin to, lalabas yung moment dyan, internal moment, M1. Okay, since under ng P1 yan. So, therefore, by taking summation of moment at 1 is equal to 0, considering clockwise moments positive. So, clockwise, so 900 by 7, and then minus yung M1 is equal to 0. So, yung M1 na yun ngayon, corresponds dun sa maximum possible M1. Okay, maximum possible M1 na mangyari kapag ang load natin is nagta-travel sa beam natin. So, ilan to, class? So, 900 times 7, so that is 6,300, and then the unit is, ilan ba to? Pounds, and then ito is feet. So, pound-foot. Okay, pero dahil may pagbabago sa analysis, hindi pa natin pwedeng sabihin ito yung absolute maximum moment. So, now we consider naman yung consideration ng load P2. So, sana na-gets yun, So, for M2 naman, M2 max, no, kailangan na natin siya i-consider. So, paano gagawin? So, let's say ito yung span. So, ito yung center line. So, 7, 7, center line. So, dahil M2 na tayo, so we are now considering yung load P2 saka yung resultant load. Okay, balik tayo dito. So, ang distance between them is 5.4. So, that is divided by 2. Ilan yun? 2.7. So, therefore, 2.7 dapat yung distance to the right and then to the left ng R sa P2. Okay, so, andi dito yung P2. Distance is 2.7. And then, to the left, andi dito yung resultant, which is ang distance is still 2.7. And then, to the left ulit ng resultant is 3.6, yung P1. So, let's say, andi dito. P1. So, this one is 3.6. Now, before proceeding again sa pagkuha ng reaction, first check kung logical yung magiging mga values dito. So, kung 7 ito, 3.6, 2.7, ilan to class? So, 7 minus 3.6 minus 2.7. Okay, so lumabas is a positive value. So, therefore, logical pa yung distance dito na 0.7. Ibig sabihin, pag nilocate natin dito yung wheel 2, papasok pa rin yung wheel 1. Unlike nga dito sa previous natin, no? Pag nilagay natin dito yung wheel 1, lalabas na sa span yung wheel 2. Okay, kaya nagkaroon tayo ng pagbabago sa analysis. So, going back. So, ito ilan to dito, class? So, 7 minus 2.7. So, this one is 4.3. Okay. So, kukunin natin yung mga reaction. RA, RB. So, ang gagawin natin, di ba, kukunin natin yung moment under dun sa load 2. So, ngayon, kakat natin yan. So, anong ko-consider mo, class? Left or right? So, dun tayo sa right. Okay? So, kung sa right ang i-consider, so, kunin natin tong RB. So, therefore, take tayo ng summation of moment. At A is equal to 0, considering clockwise moments, positive. So, ito yung resultant, clockwise. So, ilan yung resultant nito, class? Dahil pasok pa silang dalawa, so therefore, ang resultant is 3,000. So, 3,000 times the moment arm. 3.6 plus 0.7. Susulat ko na lang. And then, ito, RB. So, counter sa minus RB, the moment arm is 14 is equal ngayon sa 0. So, RB equal ngayon saan, class? 3,000 times 4.3 divided by 14. So, RB now is 921.286 pounds. Okay, so check ko lang ulit, class, no? So, 3,000 times 3.6 plus 0.7 divided by 14. Okay, so yun talaga yung value. So, may RB na ako. Ngayon, cut ko na, na-isolate ko na tong right section. So, ganito. So dito merong 921.4286 and then dito lalabas yung moment, no? So, consider natin yung positive bending moment. Ganyan. So, this one is yung ating M2. So, yung distance nito is 4.3. So, now we're ready to solve for M2 by taking summation of moment at this point, which is 0.2 is equal to 0, considering clockwise moments, positive. So, clockwise, M2, counterclockwise, minus 921.4286 times the moment arm, 4.3 is equal to 0. So, solving for M2, which is now, siya ngayon yung maximum possible value ng M2. So, ilan yan, class? Okay, so sagot is 3962.14. The unit is pound foot. Okay, So sabihin nyo na yung pinakamalaking value ng M2 na mangyayari kapag nagta-travel itong mga wheels natin along sa span ng beam. So again, may nakuha tayong dalawang moments. So 6,300 and then 3,962.14. So therefore, ang maximum moment, no, is yung larger dun sa dalawa, which is 6,300 and then pound foot. Okay? So, ganun lang siya, no? So, nangyari dito, kailangan natin i-consider, no, yung dalawa nga ulit, since nagkaroon nga ng pagbabago doon sa analysis neto, since yung P2 is lumabas na doon sa span natin. Okay? And then, next is yung maximum shear. So, for the maximum shear, ang gagawin natin is, ilolocate natin itong loading natin wherein yung resultant is nearest doon sa support. So, since, kung titingnan natin ito, yung resultant is mas malapit siya sa wheel 1. So, ito, pag nilagay natin ito doon sa beam, saan natin lalagay? Is it dito or doon sa kabila? So, dito, no, para mas malapit siya sa support dito. Okay, so for this case, for Bmax. So for Bmax, so ang gagawin natin along the span, ilolocate natin ito doon sa left side. Okay, so therefore dito natin lalagay yung P1, andi dito yung resultant, which is, ang distance is 3.6, and then to the right is yung P2, which is, ang distance is 5.4. So kung ito is total is 14, ilan yung matitira dito? 14 minus 3.6 minus 5.4. So may matitira ditong 5. Okay, and then dito merong reaction at A, and then dito is merong reaction at B. So since ang ginawa natin, yung resultant is nilapit natin siya sa RA, so therefore yung value ng RA na to corresponds doon sa ating maximum shear. Okay, so ngayon gagawin natin, kukunin lang natin tong RA. So paano gagawin yun, class? E di mag-take tayo ng summation of moment at point B equal now sa 0. So considering clockwise moments, positive. So ito clockwise, so that is RA times 14. So yung resultant na lang yung yung moment ko. So minus yung resultant, ilan to, class? Diba 3,000 yan? Kasi since lahat ng load is nandun sa span. So 3,000 times the moment arm, ilan to? 5.4 saka 5. So 10.4. So equals 0. So ilan ngayon yung RA, which corresponds dun sa ating maximum shear. So 3,000 times 10.4 divided by 14. So sagot is 2228.57, and then the unit is pounds. Okay, so ito na ngayon yung ating largest possible value na shear. Okay, so let's check kung tama ang ating mga sagot. So 6,300 for the maximum moment, and then 2228.57 for the maximum shear. Okay, so hanggang dyan na lang muna, class, yung ating discussion. So ang mga na-discuss na natin is hanggang 2 wheels, no? So sa next video natin, i-discuss naman natin paano mag-analyze kapag 3 wheels na. Okay, so hanggang dyan na lang. So thank you guys for watching, and God bless.